online tutorial. Now before us, it is beautiful exponential equation, and it said the square root of x all over x all raised to the power of x minus 1 equals x all over the square root of x, all of them raised to the power of x minus 3, and we are told to solve for x. Okay, now let us recall that each of these terms you see in the bracket here represent the base, and x minus 1 here is the exponent to this, while x minus 3 is the exponent to this. Okay, now let us recall that according to the law of indices, that when you have a raised to the power of n minus m, okay, is the same thing as saying a raised to the power of n all over a raised to the power of what? M. Okay, now since we know that this is the base, okay, let us apply this rule to the two sides of the equation. So this will give us the square root of x all over x, all raised to the power of x. Okay, now all over the square root of x all over x. Okay, now equals the same thing here. We have x all over the square root of x all raised to the power of x, then all over x all over the square root of x all raised to the power of what? 3. Okay, now you get to notice something, that this base is having an exponent of x and this base is having an exponent of x. So if we kind of switch, okay, why this come over to this and this one move over to this side, so we have something like the square root of x all over x all raised to the power of x, then this one coming over here, then we have x all over the square root of x all raised to the power of x, then equals then the square root of x all over x, then all over this x all over the square root of x all raised to the power of what? 3. Okay, now since we can see that they would have the same exponent, now we can merge them. So we have something like this, that the square root of x all over x all over x all over the square root of x, everything raised to the power of what? X, then equals, now you get to see that this base here on the denominator is the reciprocal of this, and also this is the reciprocal of this. So we can actually do something here. We can say this is the square root of x all over x, okay, then all over, flip this base. By flipping it, this one becomes negative, so we have the square root of x all over x all raised to the power of what? Minus what? 3. Okay, all right, so let's bring this over to this end. So this same thing as saying the square root of x all over x, okay, now divided by x all over the square root of x. Why I'm doing this is just for us to understand all the concepts, then equals, now since they have the same base, we can apply this rule here. So we have that the square root of x all over x all raised to the power of, take note, this is 1, so this will be 1 minus minus 3. So 1 minus minus 3 will give us a 4. Yes, 1 minus minus 3 will be 1 plus 3, giving us what? 4. Okay, so let us do this. So here we can now say this is the square root of x all over x times the square root of x all over x. I guess this one is having x, sorry, this is having x, this is having x, then this is equals to, now let us distribute this 4 to both sides of the equation, to both sides of the fraction. So you have x raised to the power of 4 all over x raised to the power of what? 4. Now we'll multiply this, the square root of x times the square root of x will give us what? X. Then all over x raised to the power of 2 all raised to the power of what? X. Then here, take note that the square root of x here is the same thing as x raised to the power of 1 over 2, taking raised to the power of what? 4, right? And when we multiply, we end up having 2. So when we end up having 2, that will be this 1 over 2. This will give us 4 here. I mean 2 here, 1, 2 here, 2. So we end up having x raised to the power of 2 for the numerator. Here you have x raised to the power of 2 all over x raised to the power of what? 4. Okay, now this here, then we have 1 all over x all raised to the power of x, then equals this here. Here you have 2, you have 1 all over what? X squared, right? Okay, so this now can be likened to saying this is x raised to the power of x, okay, then equals x raised to the power of 2. Now you might be asking why. Now if we distribute x 1 raised to the power of x, it's just something like saying let's say 1 raised to the power of x all over x raised to the power of x, and anything as long as it is 1, and so it is only it is always 1. 1 raised to the power of anything is what? 1. So equals 1 over what? X raised to the power 2. So if this one is 1, so we can actually say x raised to the power of x equals what? X squared. So at this point, let us now apply the natural log, which is the ln. So we have the ln x raised to the power of x, then equals ln x raised to the power of 2. So, and according to the law of logarithm that says log a raised to the power of n is same thing as n log a. So apply that here. We have x ln x equals 2 ln x. Okay, now bring 2 ln x to the right hand side, to the left hand side. We get to have that x ln x minus 2 ln x equals what? 0. Okay, now don't make the mistake of saying x and x because they have the same base. X equals 2. No, when you do that, you might unknowingly cancel out one of the solutions. So by doing this, now you can see we have a common term, which is what? Ln x. So we can factor that out, ln x into, that will be x minus 2 equals 0. So since we have two terms, the product of two terms equals 0, it implies that ln x here will be equals to 0 and x minus 2 here will be equals to 0. Now for this, x will be equals to what? 2, right? Now at this point, let us apply the exponent. So let us raise both sides by exponent. The exponent, you have e raised to the power of what? Ln x equals what? E raised to the power of 0. Now this will eliminate this, then we are left with e equals to x rather equals e raised to the power of 0, and x raised to the power of 0 is what? 1. So our x here equals 1 or 2. Final answer. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.